Hello everyone, and welcome to your video which is exploring the theorem of intersecting chords. So now you already know what a chord is. If we have a circle, a chord is just a line segment that has its endpoints on the circle. And you can have big chords, you can have little chords, you can have chords that go directly through the center of the circle, and we call those diameters. You can have any number of chords in a circle, and you can draw them pretty much wherever you want. What mathematicians do is they sit around and they look for patterns in life. They try to figure out, is there a rule that applies to every chord in every circle that has ever been drawn? That's what they think about. And fortunately for us, there were some very smart mathematicians who came before us, and they figured out some super cool patterns about chords, and we are going to learn one of them called the intersecting chords theorem. And what that theorem says is, if any two chords of a circle intersect, then AB equals CD. That's what it says. Go ahead, write that down in your notes. While you're writing that, I'm going to draw another circle for us to look at. So here we have a circle, and I'm going to draw two chords. I'm going to draw a pink chord right here, and I'm going to say that I also have a green chord right here. And now this is going to get labeled. This is part A of the chord, and this is part B of the chord. And this is part C of the green chord, and this is part D of the green chord. And what the intersecting chords theorem tells us is that if you take A times B, you get the same as C times D. Not A plus B, right? Because this chord doesn't have to be the same length as this chord. But A times B equals C times D. So let's say, for instance, and here I'm going to just make up some numbers, so just go with me. Get a good color. Okay. So let's say, for instance, that I know that this is 9. And I know that this is 4. And then let's say that I know that this one is 8. What is B? What is B? That's a good question. All right, well, let's say that we write down our formula, AB equals CD. A is 8, B we don't know, so we're just going to keep calling it B, equals C is 4, and D is 9. That little dot means multiplication. So we have 8B equals 36. Divide both sides by 8, and we get B equals whatever that is. Let's find out. 36 divided by 8 equals 4.5. So the length of this part of the segment would be 4.5. Isn't that cool? Yeah, I think that's pretty cool. That is the intersecting chords theorem. And amazingly, it always works. Interestingly enough, it also works if your chords are a little bit different. So for instance, let's have your circle, and then let's have this chord and this chord. And let's say that this chord is, I don't know, let's say, what does that look like to you? That looks like a 10 to me. And this looks like an 8 to me. and this looks like a 9 to me, and so we want to know the length of that. Well, same thing. First, let's look at one chord. We'll call this AB. So 9x equals CD. 8 times 10. So 9x equals 80. Divide both sides by 9. X equals, I need my math. It's almost a 9, but not quite. 8.88888888888888. So that is the length of, I said X. Oh yes, X is what it is, right there. So that is the length of that. So that would be 8.8. Isn't that cool? Yeah, okay, so that is the intercepting chords theorem.